In this box is a Tomlov DM9 digital microscope, and in this video I'll be unboxing the scope, putting it through its paces and giving my thoughts on whether you should get one. We'll start with unboxing and assembly. The first thing we come across is the user manual, and I'll put this to one side as it might be useful later on. Next we come to the main part of the unit. The 7-inch Full HD display and the microscope are combined into a single part, so you'll want to be careful with this when taking it out of the box. Removing the plastic tray, you'll find the base of the scope and the bracket used to attach the display to the base. The scope also comes with a few accessories, including a USB Type-A to Type-C cable for charging the battery, a remote control to allow easier operation of the scope, and a 32GB microSD card. Also included is this light reflector, though I'm not entirely sure what this would actually be useful for. A quick note on the included microSD card. You'll want to keep this around even if you plan to use your own, for reasons that we'll see later on. Taking a look at the specifications, I've noticed a few inconsistencies with how this scope is being marketed, so I'll go over a few of the claim specifications and take a look at what you actually get if you purchase this scope. To start, the Tomlov DM9 comes with a 7-inch display. On the Tomlov website, this is advertised as being HD, but looking a little further down, you'll actually note that the display resolution is 1024 by 600 pixels, so this is certainly not an HD display. Though alongside the display resolution, 1080p HD is also listed. My assumption is that this claim is related to the fact that the scope does record 1080p video, which you're then able to watch back on the built-in display. Of course, that doesn't mean it's been displayed at full HD, but I'm guessing that's where this claim is coming from. If the display quality is important to you, Tomlov themselves do sell more expensive scopes that genuinely have a full HD display. The site also lists the scope as being capable of creating photos up to a resolution of 12 megapixels. In fact, the scope goes all the way up to 16 megapixels, so you're actually able to produce photos of a higher quality than is listed on the website. The display is claimed to have a tilt of 90 degrees, and in my experience it's actually a little bit more than that, although you're unable to fold it entirely flat as the graphic on the website suggests. It also advertises a 270 degree range of rotation, and actually because of the way the display unit sits onto the base, you're actually able to rotate it the full 360 degrees. The height of the scope is listed as being 8.5 inches, and I have no idea where this 8.5 inches has been measured, because I can't find anything that actually matches up to that size. The height of the attached bracket is actually around 6 inches, or 15 centimeters, though there's a little gap at the top where you're unable to raise the arm holding the display any higher. Of course, there's also a limit to how far you can lower it before it hits the base. And to just give you an idea of the actual range of motion that's available, with the display raised as far as it will go, you actually get around 6 centimeters between the lowest part of the lens and the base, which equates to about 2.5 inches. The site also shows a micro USB port on the display unit, whereas the one I have here has a USB Type-C port. This is used to both charge the scope and to connect it to a PC. I've tried charging the scope with a USB Type-C power delivery capable charger, and it was able to charge the scope, albeit slowly as it does not have any fast charging capability. As ever with these sort of scopes, the site also makes a claim about the level of magnification possible. In this case, it's advertised up to a 1200 times magnification. I'd caution against reading too much into these numbers, because it's not always entirely clear how they've actually came up with them. we'll take a look at some real world video clips and photos that were created from my scope later on in the video, which should give you more of an idea of the sort of magnification which is possible. So all in all, the specifications on the website are a bit of a mess when compared to what I've actually received. Now of course, depending on where you buy this from, you might get a more accurate set of specifications, though hopefully some of what I've shown here should help to clear up some of those discrepancies and give you a better idea of what you can expect to receive. Assembling the scope is pretty straightforward, as there are only a few pieces that need to be fitted together. You'll want to start by screwing the bracket into the base. Once it's mostly screwed in, you'll want to make sure that the mounting bracket is aligned correctly with the base. Once it's positioned correctly, you can then use the screw collar to secure it in position. It's a good idea to adjust the mounting arm at this point to move it as far away as possible from the base. This will make sure that there's plenty of clearance when trying to fit the display unit. You might need to tighten the screw on the rear of the bracket to ensure that it holds its position. Attaching the display unit is incredibly simple. Simply slot it through the hole in the end of the arm on the bracket and use the 3 thumb screws to secure it in place. The final step is to plug in the controller. You don't technically need to do this, as you can control the unit from the buttons on the display, but it's certainly much more convenient to have this plugged in. There are 2 connectors on the controller, a micro USB cable which plugs into the base, and what looks like a headphone plug which connects to the display. Now that the unit's assembled, let's take a look at some of the photos and video clips that I was able to capture using this scope. In terms of the video quality, the scope records in the AVI format. This means that the video will have been converted in the process of making this YouTube video. This will have had a small impact on the video quality, though it's still representative of what you can expect to get out of the scope. All video clips were recorded at the Full HD resolution of 1920 by 1080, which is the highest possible with this scope. The first thing I wanted to do is get a rough idea of the size of the area that the scope is able to see. In the fully raised position, we can see that the viewing area is approximately 2 centimeters wide, or just under an inch. Moving the ruler to the side, we can see the height of the viewing area is just over a centimeter, or just under half an inch. Zooming in as far as I can, while still being able to move the ruler slightly, we find a width of just over 3 millimeters, or 1/8 of an inch, and a height of around 2 millimeters, or 1/12 of an inch. Here we have a close-up shot of a small PCB, which is designed to mount a USB Type-C port. We have a nice clear view of the board, and it should make soldering a little easier. If we zoom it in further, we can get a really close-up view of some of the pads. This will be really useful for checking for bridged solder joints, or when dealing with very fine traces and pads. I also had a little play with some of the lighting. The scope lens has a ring of LEDs, which are adjustable using the control on the side of the display. There are also 2 gooseneck lights, which are attached to the base, with the control at the rear. We'll look a bit more at these lights later on. Here we have the inside of an Xperia Z3 tablet compact. We have a close-up shot of a damaged connector. One thing to note with this scope is that the video output videos can look quite soft and grainy, and almost have a slight cartoonish quality to them. This clip here is a good example of that. Good lighting and ensuring the focus is set correctly definitely helps. It's much more prominent when you're looking at something with an uneven surface, where you have to effectively choose which part of the object that you're going to focus on. In this clip here, we've focused on the connector, which is why everything around it looks a little blurry. Before moving on to the next clip, I wanted to warn anyone that might be a little squeamish, as the remainder of the clips will feature close-up shots of insects. I think they're really interesting to look at, but I understand some people might not want to see it, so here's your chance to skip past these couple of clips if it's not something you'll want to see. We'll start with a close-up look at a fly. What really stands out here is that there is enough detail to see the complex lens structure of the eye. We can also clearly make out the fine hairs which cover the fly's body. After adjusting the focus, we get a clear view of the structure of the wings. Next, I decided to take a closer look at one of the leaves from a succulent plant I have, which is not doing particularly well. I was hoping to find what was causing the issue, and as we can see, I think I managed to find it. Now, I'm not entirely sure what bug this is, but there were also a few larger ones present, which have a black body. Presumably, those ones are adults, and what we're looking at here is one of the young. I find this particularly interesting as, due to the translucent body, we're able to see the inner workings of the bug as it devours my succulent. As an aside, if anyone knows exactly what this is and how to get rid of it, I'd be very interested to hear. Moving on from videos, I also decided to try out creating a few photos. This first one is a photo of one of the black bugs from the succulent that I assume is one of the adults. Next, we have a close-up look at a mosquito larva. We'll end with another look at the fly. All of these photos were created at the highest quality setting of 16 megapixels with a resolution of 4608 by 3456. Quality generally seems good, though as with the video there is some softness present. Now we've seen what the scope's capable of, I wanted to take a look at what the scope's like to use and discuss a few of the issues that I've had with it. To configure the scope, there is a small settings menu available, which, just like the settings menu on your monitor, is a little bit fiddly to try and navigate, though I do find it much easier to do this with the controller than with the controls directly on the display. When in photo mode, you'll get options to change the resolution, the image quality, the sharpness, and the exposure compensation, as well as having the option to enable a burst shooting mode. Switching to video mode, you have a much smaller set of options available, only being able to change the resolution and the exposure compensation. There's also an option to include or remove a date tag from the recording. To access these specific setting menus, you need to make sure you're in the correct mode beforehand. The settings for video recording are only available when you're in video recording mode, and the same is true of the photo settings. The menu also contains a second page which is the more general settings, which is available regardless of which mode the scope is currently set to. This menu includes core system settings such as the language and the date and time, as well as options to format the SD card and view system information. While this scope doesn't have the ability to directly connect to an external display, plugging the scope into your PC using a USB cable gives you the option to view the output on your computer. You can view the output using any application capable of reading a camera's input, for example the Windows Camera app. While this is an interesting feature that I'm sure some people would find useful, the video resolution is limited to 720p. This is a higher resolution than the 7-inch display is capable of showing, though if you're looking to record your video, you'll only be able to record in 1080p if recording directly to the microSD card. When plugging the scope into the PC, you'll also have the option to mount it as a mass storage device, and this gives you access to the microSD card without having to remove it from the scope. I find this a very useful feature, as I'm much more likely to have a USB cable lying around than a microSD card reader. When I first started using the scope, I wanted to use my own microSD card, and unfortunately I had a strange issue where I was unable to see any of the captured content on PC. The included microSD card worked perfectly fine. Plugging the microSD card into the scope, it was clearly able to recognise the card, and I was able to format it using the scope's built-in formatter. After doing this, I was able to start using the card as normal, with the remaining photo capacity updated in the scope's UI, reflecting that the card is now usable. So far, so good. The issue came when plugging the microSD card into a PC to take the footage off the card. When plugged in, the Windows prompt pops up, asking for the drive to be formatted. Once formatted, I plugged the microSD card back into the scope. While it did detect a card was inserted, unfortunately it is showing that there is no space to store any more photos, and trying to capture one results in an error message. To try and solve this, I first tried replicating the folder structure from the included microSD onto the new card. I also tried copying the partitions directly over, just in case there was something about the way they were formatted which was allowing it to work correctly. Neither of these attempts were successful, but after a bit of digging, I did manage to solve the problem. It turns out that the microSD card I wanted to use has a GPT partition table, and once I recreated this with an MBR or MS-DOS partition table, the card was working correctly. It's possible to convert a GPT partition table to MBR, but I don't know of any graphical tool in Windows that is able to do this. And I did try using the diskpart command line tool, but unfortunately this didn't work correctly either. Instead, I used a Linux machine to create a new partition table, though you should be able to do this with some third-party tools in Windows. Just make sure that you choose the MS-DOS or MBR option. And for those of you that have no idea what I'm talking about, fortunately you're very unlikely to come across this problem, as microSD cards typically would be set up in a way that will work with the scope. However, I did want to mention it because if I encounter this problem, it's possible that someone else will as well, and it's a simple enough one to fix once you know what you're actually looking for. It's a shame that the formatting tool built into the scope isn't able to handle this. Another minor niggle I have with the scope is that I don't find the controls particularly intuitive. Quite often find myself pressing the wrong button, but I'm sure that's something I'll get used to over time. A final niggle that I have is that the viewing angle of the screen is rather poor. Of course, this is somewhat mitigated by the fact that the screen is so adjustable, and if necessary, I know there's always the option to view the footage on a PC instead. So to conclude, overall I'm very happy that I purchased this digital microscope. It's one of the cheaper options on the market, but it does everything that I need it to do. The video and photo quality is generally good, and the screen is adequate for my uses, though there are more expensive options available with larger and higher quality displays. It's missing a few features found on more expensive models, such as the ability to connect an external display. So consider how important those sort of features are before you choose which scope you wish to buy. I hope you like this video. Thank you very much for watching, and be sure to stick around for the next one.